Hey everyone, today we'll be solving LeetCode problem number 169, majority element. In this problem, we will be given an array nums of size n and we have to return the majority element. So what's a majority element here? The element that is appearing more than n by 2 times in the array. And we can assume that the majority element will always exist in the array. There is no negative case. Okay, so we will be given an array nums. Let's say if I take an example 2 2 1 1 1 2 2 of length. Here what is the value of n? 3 3 6 and 1 7. 7 is the length. So what will be the majority element? Majority element is coming having a frequency more than n by 2. Floor value 7 by 2 is 3. So if any element is having frequency more than 3, that is going to be my majority element. 2 is coming 4 times. 1 is coming 3 times, so it's not greater than 3. So 2 will be our answer in this case. So how did I do in this case? Let's take a look on the brute force. As this is my array, what I'm going to do is taking every ith element and see what is the number of time that element is coming in the array or not. So 2, I will iterate over this array and 2 is coming 4 times at the next index, which is also 2. I will iterate again. It is coming 4 times. So 4 is already captured. 2 coming 4 times already captured. Now I'll come here, and here I value is having a value 1. So 1 I will see in the array, it is coming 3 times, so it's not greater than 4. Same with these two 1, and then at this one, this is 2 and 4 already captured, 2 and 4 already captured. So here it is taking an operation for every n value in the array. So ultimately the time complexity of the brute force is going to be order of n square. Are we taking any extra space here? No, we are not taking any extra space, but the time is too high. It's going exponential in terms of our number of elements in the array. So as the n square is very high time for us, so can we have a better time? Here the array is already given and we just have to know how many time any specific number is coming. So for that we can directly use hashing. Hashing will mean capturing the frequency of each element, and we can use a map for that, where key would be our element and the value would be the frequency, the number of times the element is coming in the array. So we will just keep on updating this map while iterating over this array. So firstly we have 2, so 2 is coming one time. Now at the next index we are also having 2, so 2 is coming 2 times. Now we have 1, 1 is coming one time. Now 1 is coming 2 times. 1 is having 3 times in the array. We have 2 again. 2 is already 2's entry is already in the map, so we will update that. 2 is coming 3 times, and in the end, so ultimately our map will having a state like this. Key 2 is having a value 4, key 1 is having a value 3. This is our frequency map, and in the frequency map I can see whether any element is having a frequency more than 3, because the size is 7 and 7 by 2 floor is 3. So here 2 is having a frequency more than 3, so 2 is our answer. Now let's try to see what is the time and space complexity here. What is the time complexity? We started with this index I equal to 0 and we reached till I equal to n minus 1. We only did one iteration, nothing else. After that we did iteration over the keys. Keys are already less than this n. Let's say it is n or it is m, some lesser value than m. So ultimately the time would be order of n. And what is the space here? Space is that we are storing the frequency of each element, and in the worst case it can go till order of n. So this is the space and time complexity if we are using hashing, which is a lot better than the n square. Here we have solved it using of order of n space, order of n time, and the order of n space. But they have added a follow-up question that we have to solve it in the order of one time. So for that we have a specific algorithm which is called Moore voting algorithm. It's a pretty standard problem. That's why the problem has been asked in many companies like Amazon, Facebook, Uber, Apple, etc. So in this problem, what is our intuition is that, let's say we are considering the same example. Let's say if we consider that I equal to 0 is the majority element, so that element should be more than n by 2 times, and all the other element inclusively are less than n by 2 times. At any subset, let's say this is the subset that I have considered an element 2. So 2 is there as a majority element. So it means I will also keep track the count. 2 is coming one time. Here 2 is coming two time, and 1 is coming one time. So if 1 is coming one time, it means that we can reduce our majority element count, because 2 is coming two times is specifying that our majority element, our candidate to majority element that we like assumed to be a majority element, is coming two times. So if there is one, it means that is a minority element, and that will like remove the effect of one majority element. So it will cancel out 1 2. So 2 is coming one time. It means that in this array 2 is having a majority element, because after cancelling out all the majority and non-majority element, we still remaining with 1 2. It means 2 is coming more than n by 2 times in this subset. If I taking a subset of first 4 element, 2 2 1 1, and then if I take another one as well, let's see, we have 1 here. So if 2 is the majority element, 2 is coming 1. It means 2 is the majority in this element. And here if I consider the first two element, 2 is coming two times. Okay, that is fine. It is showing me that 2 is a majority, still a majority element. Now we have 1. 1 is not a majority element that we have pre-assumed, so it will reduce a 1 effect of 1 unit. So 2 will be 1 now. It means that after cancelling out majority and non-majority element, equal number of majority and non-majority element, we are left with this majority element, which is 1. If it is greater than 0, it means yeah, this is definitely a majority element. Now we come to this one. Here the 2 will be reduced to 0. 2 is reduced to 0. It means that 2 is no longer a majority element. So in the array 2 2 1 1, here 2 was majority, here 2 was majority, here also 2 was majority, but as a whole array 2 2 1 1, 2 is not a majority element because 2 is not coming more than n by 2 times. So we are discarding 2. And as 2 is not a majority element, so why should we like pre-assume that 2 is a majority element? We'll discard 2, and at this index we will assume this one as our new candidate to majority element. And now we will use the same logic now onwards. So we were having 2 2 1 1, okay, then again 1, and then 2 2. So we got to know that at this point, earlier we assumed that 2 is a majority element. Then later on we saw 2's count has been increased from 1 to 2, then 1, then 0. If 2's count is 0, it means that in this array 2 is not a majority element. And as 2 is 0, it means we have same number of majority and non-majority element. That is, we are discarding this effect. If we do not consider this block, it will make no sense. And we are starting from this. We considered that new majority element is 1, and we will start capturing the frequency of this. New majority element is 1. 1 is coming one time. Count 1 is specifying that this 1 is a majority element, and now we'll consider these two element 1 comma 1. Now majority element count is 2, and here at 1 1 2, majority element count is equal to 1, because 1 2 is cancelling out this one, and this 2 will cancel out this one. So in the later 1 1 2 2, we don't have any majority element. All the elements will be cancelled out. But here at this moment, majority element count is coming to 0. It means we are updating our majority element to this element, that 2 can be our candidate to majority element. Okay, so now after this operation, what we got to know that we have one candidate captured in our majority element. that this item can be a possible candidate. So how do we make sure that this is definitely a majority element? We'll just iterate over the array again, whether it is coming more than n by 2 times, it is a majority element, otherwise just discard it. But we are given that we definitely have an answer. So ultimately this is going to be our majority element. And we don't need to check again whether this is definitely a majority element or not. Let's take a bigger example. Let's say we have 7 7 5 7 5 1 5 7. Okay, let's say this is our array. Here we are assuming that our majority element is 7 and majority element count is 0. No, it is 1. We are at first index. So we are going ahead and we will see whether it is equal to majority element or not. If it is equal to majority element, we'll like increment the count of majority element. Now come again, it is 5. 5 is not equal to majority element, so we'll decrement the majority element count to by 1. Now the majority element count is still 1. It means that in this subarray, still the 7 is the majority element. Okay, now come again. Now we have 7 again. So 7 count will be incremented to 2. Now we have 5. So it will be decremented to 1. And we have 1. So it will be decremented to 0. Okay, as it is a 0, it means till this subarray we have 3 7 and 5 5 1, 3 non 7. So there is no majority element in this. So we will start from here. We have 5 and 5 is a majority element and majority element count is 1. Now we have 7. 7 is not equal to 5. It means that our majority element count will be reduced to 0. As it is reduced to 0, we will also update our majority element to the current element, which is 7. Now the majority element is 7 and majority element count is 1. Now as we have iterated over this array, we'll just see the majority element, whether this majority element. Okay, we have the majority element, so this is a possible candidate to our answer. So we have two possibility: either it is a majority element, definitely a majority element, or this is not a majority element. If this is not a majority element, there is no other majority element in this array. But as per the problem statement, we are given that we will definitely have the answer, so we can directly return this value. So this is our Moore voting algorithm. Here what time we have taken is order of n, and what is the space complexity. Instead of iterating over this array, we did not take any extra space, so it will be a constant space solution and the linear time solution. Okay, so the main idea behind this is like whether we will choose a majority element, and if there is equal number of majority element or known majority element, we will just discard that set and we can start from the current element. Okay, I hope you understood the approach. Let's code this out. Its code is going to be quite simple. First of all, we will take a element which is the majority element. Let's say the first element is the majority element, and the majority element count MEC, which is 1 in the starting. Let's also capture the length nums dot length. Now we will iterate over this nums array from I equal to 0. Okay, let's start from I equal to 1 because we have already captured I equal to 0 as a majority element. I less than n, I plus plus. Now we have two conditions: whether the current element is equal to majority element or it is not the same. If nums of I is equal to majority element, what do we have to do here? Just increment the count, majority element count plus plus. Otherwise majority element count minus minus. Here while reducing the majority element count, we will see whether at any point it is equal to 0. If it is equal to 0, it means that we have to consider a new majority element candidate. If majority element count is equal to 0, we will discard the current majority element. New majority element would be nums of I. Majority element count will again be 1. Now this ME is the majority element candidate. But here in the problem it is already given that we can assume that the majority element will always exist. So in this case, this candidate is definitely the majority element. Let's submit our sample test cases. It should be nums. Sample test cases are passed. Submitting the problem. It is submitted successfully. Hope you understood the problem. Thank you guys. Here we use the Moose voting algorithm to find the answer in the order of n time and constant space. Bye bye.